The smartest things in this universe are from nature, and the smartest of all is the human brain. The human brain is a very capable machine of recognizing patterns. Alan Turing proposed a theory to help explain a series of patterns that occur repetitively throughout the natural world. Can we explain these spots on leopards and stripes on zebras mathematically? Alan Turing's paper, The Chemical Basis of Morphogenesis, talks about how patterns in nature, such as stripes and spirals, are formed, and argued that pattern formations was far from random. For example, taking the case of a leopard and a tiger, which has spots and stripes respectively, patterns emerge from randomness as the varying concentrations of color-activating and color-inhibiting chemicals interact. In the tissues, when the embryo is forming, these activating and inhibiting chemicals are responsible to generate the colors uniquely for each species. This process of the platform formation is termed as reaction diffusion. Schnackenberg has proposed a mathematical model for this reaction diffusion process when two interacting chemicals are involved. This equation helps to calculate the relative strengths of reactions and diffusions over a period of time for chemicals A and B. Here, alpha, beta, and gamma measure the relative strengths of the reactions and diffusions. So, why do we want to represent nature in maths? Well, we have been plagiarizing many things from nature for efficiency and calling it biomimicry. Representing nature in a language understood by everyone, fitting the known laws, is an easy way to explain things. What's a better language than maths? My favorite example of biomimicry would be this Olympic Stadium in Munich, designed by German architect Frei Otto. He used soap films to model the sails of the Olympic Stadium, and he relied on nature to form the best durable shapes. Coming to the field of chaotic patterns formed in nature, like our clouds, snowflakes, and others, we have defined a unique field called fractal geometry, developed by Benoit Mandelbrot. A fractal is a never-ending pattern that repeats itself at different scales. The COVID-19 virus has a corona which resembles a fractal. Not only is its shape a fractal, but its behavior is a fractal. Viruses are more active as they have higher metabolic rates. These viruses tend to be more fatal because of their fractal geometry. These fractal formations with unsmooth surfaces having higher fractal dimensions are deadlier than infected sphere cells. Better understanding the fractal geometry of the corona structure of these viruses could help us find a vaccine to end this pandemic.